I'm John Hall. I'm the Group Operations Director for Belgravian Technologies plc, and I'm responsible for the research and development for TouchStar. TouchStar design and manufacture mobile computer terminals and also the software applications that go with them, predominantly for the fuel industry, for van sales and in-flight onboard point of sales for airlines and trains. But today we're actually going to focus on a new terminal, Hawk 2, which is focused specifically on the fuel industry markets that we deal with. Designing the mobile computers involves many different disciplines. An in-depth knowledge of the target industry and its needs and aspirations is imperative. We have an excellent understanding of the business benefits they want to derive from implementing this type of technology. And of course, we have to deliver the industry standards to which the equipment is required to conform. We also need extensive understanding of the current and emerging technologies. This is with respect to the processors, the new battery technology that's coming online, the memory advances that we're seeing in the marketplace. And we take all this information and combine it into what we hope is an innovative product which will bring innovation to the fuel industry. It's worth just looking at ATEX and IECX compliance. Any equipment that's actually designed to work in potentially explosive atmospheres must actually be tested to ensure that the equipment won't generate enough energy to ignite the explosive atmosphere that it's working in. There are multiple levels of accreditation depending on the type of gas that is present in the atmosphere. One of the overriding tests that we have to comply with is the physical stress test on the enclosure to make sure that within the from the date of manufacture to 10 years after its date of manufacture, the case will not be compromised. This involves a number of tests, heating it up, the enclosure up in an oven to 80 degrees C at 90% humidity and leaving it in that environment for 28 days, then reducing the temperature to -30 and dropping an enormous weight on it to make sure that the case doesn't fracture, smash and expose the electronics within. So having passed that test, then there are a number of drop tests that the terminal must achieve without, again, any violation of the case integrity. So when we're looking at designing a product like this, from the outset, the Hawk development team were tasked with developing a new terminal for the fuel delivery sector that fully meets all the criteria specified by our customers. And indeed, it's not just the specification now, but we need to look 5 years ahead at least to make sure that we capture any market changes in that period. We utilise some sophisticated tools for designing and analysing the housing to ensure that even under extreme environmental conditions, the integrity of the enclosure isn't compromised. This is done using CAD to model a combination of different stress factors and to predict areas of weakness. From this we can actually determine where these stress factors are, redesign it to ensure that we've got those covered, and also use this to select a plastic that will survive and endure this hostile environment. The state-of-the-art electronics development tools facilitate extremely rapid development of extremely complex, highly integrated mobile computer platforms. When embarking on a development of this type, the first thing we need to do is understand where the equipment is going to be used. So we do this through a series of visits and a series of focus groups with the end user and our technical team. Above all, when we put the terminal in the cab, it must have a minimal impact on what the driver is doing. So therefore, we need to have lots of options, places to actually fit the terminal. So we keep the terminal small, we keep it sleek, we have flexible mounting options to allow you to mount it in various places in many different types of cab. We need excellent acoustics because we are probably going to be conveying information to the driver about where he's going and what he's needing to do next. We need a large clear screen so we have clear visibility, so in any lighting situation, whether it's bright sunlight or it's dark and nighttime. So when designing the user interface, we need to ensure that drivers with large hands, perhaps even gloved, can operate the terminal touchscreen easily and effectively. We need a quick release cradle because the likelihood is we're going to want to take the terminal out of the cab and go and collect a signature on the forecourt. We also need to be able to put it back easily, so this procedure needs to be simple and effective. Because the terminal is going to be used indoors and outdoors, we need to make sure that the terminal is sealed against the elements, but we also need to consider that the driver may have oil on his hands, petrol on his hands, so we need to ensure that we have totally sealed the enclosure against liquids and dust. Because this terminal is going to be used in extremely harsh environments and subject to extreme vibration and impacts, we have to protect the electronics within. We've learnt over many years that not to do this can cause real issues. We've solved this through the use of a product called sorbethane, which totally and utterly absorbs any impact on the outside of the case and totally protects the display and the electronics within the enclosure. I think it's worthwhile just looking at the different wireless communication options that we have available to us and we have to design into the equipment. If you look at the lowest level RFID, we're often being asked to use RFID to identify individual tanks. We use Bluetooth as a local or personal area network for printers that might be kept on the belt or within the cab wirelessly. We're using Wi-Fi to collect information, perhaps back at the depot, rather than upload the data over 3G. You might want to upload it over Wi-Fi. So we have mobile broadband or 3G. We actually use extremely high speed mobile broadband, up to 7.2 megabits per second on download and 2 megabits per second on upload, which allows us to conveniently move large amounts of information around very quickly. We also use GPS for tracking. We've designed in the latest version of GPS, which is Surf 4, which gives us extremely accurate data as to the position of any vehicle at any time. So to allow GPS to work either in or outside the cab, we have links on the cradle to allow the external GPS antenna to work on top of the cab while it's in the cradle. As soon as you take it out, it automatically switches to an antenna inside the terminal itself. So our GPS is compatible with all the sat-nav applications, whether it's TomTom, PTV or Sygic, or any of the other applications that can be found that will run on the Windows CE operating system. So with respect to data collection, we're able to read both 1D and 2D barcodes. This particular type of technology that we utilise reads extremely well in direct sunlight and indeed even through glass, which can be important in these applications. We have a camera which is a 3 megapixel extremely high quality camera. This is very good for perhaps scanning documents or, as we said before, recording damage or obstructions. The RFID capability covers all eventualities, whether it's low frequency, high frequency or UHF. The battery within the Hawk 2 is an extremely important element of the design. The ability to get as much use out of the terminal with one charge of the battery is extremely important to the user. So we do this by using a combination of the latest battery technology and techniques, using lithium polymer batteries, but also managing to minimise the amount of current that's taken by the terminal while it's operating. We use an internal battery to ensure that the user never loses his information. Even if he takes the main battery out, the internal backup battery will retain that information for up to 5 days. There's also a real-time clock, which is again battery backed, to ensure that the terminal is up to date even when the main battery has been removed.